to our CO2 sequestration and storage talks. The first one will be by Professor Kiminori Shitashima, who is a WPI Principal Investigator of I²CNER in Kyushu University. Professor Kitashima had his undergraduate degree in oceanography in Tokai University and then his master's and PhD university degrees in Hiroshima. And he is an expert in marine geochemistry, and he will be talking to us about subsea bed and ocean CCS within I²CNER.
Thank you, Chairman. My name is Kiminori Shitashima of the CO2 sequestration and storage division. It's a CSS division, not CCS division. So today I talk about the subsea bed and ocean CCS in I²CNER. So I believe that nobody in this room doubts the necessity of CCS, but we have critical reason of the necessity of CCS. Because of the fuel fossil power plant, becomes more important due to nuclear power plant disaster in Japan. The CO2 from the power plant should be recovered and sequestrated in the long term. And for the realization of the carbon neutral society by hydrogen use, the CO2 which generated from the hydrogen production should be sequestrated safely by CCS. And under the unique geological condition in Japan, the candidate for appropriate site of CCS are limited. So we research about subsea bed storage as geological CCS. In the subsea bed storage, CO2 injected to the aquifer in subsea bed from the land or sea surface. And as you know, ocean CCS is not permitted by the London Convention yet. But ocean CCS is very important for Japan because we have often got aspect near shore. So we have to continue the research of the ocean CCS. And ocean CCS has two different storage types. One is deep ocean storage, and the second is mid-depth diffusion. In deep ocean storage is storage by the forming the CO2 lake on ocean floor with depth more than 3,000 meters. And in mid-depth diffusion, direct injection of CO2 into the mid-ocean depth is at 1,000 meters or 2,000 meters. So our objective and goals of CSS division objective is estimation of CCS safety and understanding of diffusion behavior and environmental impact of CO2, and prediction of long-term CO2 behavior in the reservoir and ocean, establishment of monitoring instruments and devices, and development of stable pipe system for the CO2 injection into the deep ocean. And our goal is enforcement of small-scale field experiment of CO2 injection in the subsea bed and or ocean in Japan or in northern Kyushu area. And evaluation of the safety of subsea bed and ocean CCS based on the result of the CCS field experiment, and establishment of the public consensus of CCS based on the evaluation of the safety of CCS and conduct of CCS in northern Kyushu area or in Japan. So it's the structure of the relevance of CSS group. We have three groups. One is the geological CCS group, and the ocean CCS group, and the CO2 monitoring group. Each group has a relation, is a good relation. Is for example, geological CCS and ocean CCS has a numerical simulation study, and CO2 monitoring of the geological CCS has a monitoring of in situ monitoring of CO2 behavior in high pressure in rock CO2 water phases. And ocean CCS and CO2 monitoring has a development monitoring system and a national study. And we also have our group also has a good relation with University of Illinois satellite team. For example, onshore field experiment on the CO2 droplet behavior and a laboratory experiment on CO2 diffusion. And we have some technical approaches. One is site selection. We have to decide. We have to choose or we have to decide where CO2 stored. One is subsea bed, and the other is ocean or the coal mining bed in Japan or northern Kyushu area. And second is the evaluation of the CCS safety. So we have to research about the integrity investigation of reservoir and cap rock and numerical simulation study of CO2 behavior in reservoir and stability of CO2 hydrate in deep sea floor, and natural analog study of CO2 leakage, diffusion behavior of CO2 in the ocean, and acidification of seawater and environmental impact of CO2. And third is prediction of the long-term CO2 behavior. So we have to study the numerical simulation studies of CO2 behavior in reservoirs and the effect of CO2 hydrate to acidification in deep ocean, and laboratory experiment of CO2 behavior in high pressure rock CO2 and water phases. And of course, we have to fourth is technical approaches is monitoring system of CO2 behavior. We have to have the development of CO2 monitoring instrument in geological reservoir and ocean, and also we have to develop of the CO2 monitoring devices in the ocean and the high pressure environment, and establishment of CO2 monitoring system for geological and ocean CCS. And related technology to CCS is development of stable pipe system for injection CO2 into the deep ocean. And finally, so we have to have enforcement of small scale field experiment CO2 injection in the subsea bed and or ocean in Japan. So it's a technical accomplishment of the progress, and ocean CCS group simulates the CO2 dissolution behavior in deep ocean from the such kind of the CO2 lake, and they apply to the study of the combination between engineering CDF and the ocean circulation models, and they also apply to the gaseous CO2 behavior in the shallow water in the same method. And Professor Kajiwara also developments study about stability of injection pipe in deep ocean. And geological CCS developed the high pressure experimental system in I²CNER. So they had in situ measurement and in situ monitoring of the CO2 and rock and water phase. And they also has a theoretical approach has started for the CO2 behavior in porous sandstones. And CO2 monitoring is the development of monitoring system and devices. So Professor Nakamura develops the recovery of monitoring data obtained by the V system by the AUV, autonomous underwater vehicles. and the vehicles, and the CO2 monitoring by the towed vehicle system. And I developed the in situ high precision in situ pH sensor. So I installed this pH sensor to the UV or gliders. And then, we have more another technical accomplishment. CO2 monitoring is a national analog study at the hydrothermal systems. Hydrothermal system is underwater hot springs or volcano. So this we have two purposes is a natural analog study. One is the understanding of the CO2 diffusion behavior in the sea, and the second is the efficiency test of the monitoring system and devices. So monitoring system and the devices are only tool, but I have to check that it can work in the ocean. So fortunately, we have the two different sites of the national analog sites. One is the liquid CO2 emission site in the Okinawa Trough and the Mariana Trough, and the second is the CO2 gas bubbles eruption site in the Kagoshima Bay and Taketomi Island. So I have observed CO2 low pH seawater diffusion like this. And we have many collaboration studies with domestic and international researchers. Especially, we have onshore field experiment with ISGS and Indonesian researchers. And we also have the subseabed field experiment with the UK, is a PX project and the ECO2 project. And it's the proposal future work. We have many proposed future work, but I have no time, so it's a summary. So the important thing in this summary, so we are planning conduct of, or we hope to conduct small-scale field experiment of CO2 injection in the subseabed and or ocean in the northern Kyushu or Japan. Thank you for attention.
Thank you.